right, so number 13 to 16, I call them special fractions, meaning that they are what we call proportions. So proportions is where it's one fraction equal to another fraction. So specifically, if you have A over B is equal to C over D. So one fraction equal to another fraction. And that there's exactly one fraction on one side and exactly one fraction on the other side. As you can see in the previous problems, they have more than one fraction on one side, right? So if they're more than one fraction on one side, they're not called proportions. They are only called proportions when you have one fraction equal to another fraction. So if you look at number 13, number 14 is the same, number 15, and number 16. One fraction equal to another fraction. So I heard you say that you cross multiply, and that is correct. This is a shortcut. If you ever have a special fraction called proportions, the shortcut, I mean, you can still do what we did earlier of finding the lowest common denominator and all that stuff. But instead of finding the lowest common denominator, the short is you could cross multiply. And this only happens when you have one fraction equal to another fraction. So here you're going to cross multiply across here and cross multiply across here. Right? So here I have these two things, so I'm going to cross multiply. So here I'm going to cross multiply here. So there's a negative here. You need to decide whether you want their negative on top or on bottom. I'm just going to make it easy, and I'm going to put the negative just on top. I'm going to apply the negative just to the top. I don't want to apply it to the thing on the bottom. I'm going to cross multiply, so I have negative 18 multiplied by x plus 1. So after I cross multiply those two, I'm going to say equals to the cross multiplication of the other side. So this way. So here, I have 3x times x squared minus 6x minus 7, right? So this is pretty messy. It's not like an easy cross multiplication thing where you just get nice numbers. Notice, what can I do with x squared minus 6x minus 7? Factor it, right? So when you factor things, it makes things simpler for you. So go ahead and factor this polynomial here. Okay. If I factor this, I get, anyone know? Probably x minus, so there's going to be a 7 and there's going to be a 1, right? And this is going to be a negative and this is going to be a positive. Because if you multiply these two together, you get a negative 7, and if you add them together, you get a negative 6. So notice here, the left side and the right side, what do they both have? So instead of multiplying through the parentheses, like we normally do, what does the left side and the right side have in common? What factor? X plus 1. So we could get rid of x plus 1 by dividing both sides by the common factor. So we could divide both sides by x plus 1, so therefore they'll just cancel out. Right? The left and the right, you just get rid of them because they both have the same factor. So therefore, on the left side, and when you cancel them out, they just become a 1. The left side, what do you get as an answer on the left?
Negative 18.
Negative 18. And on the right side, I have this times this, right? So here, I'm just going to multiply through just to save time instead of writing it out and then multiplying. If I multiply through, what do I get?
Negative 3x squared.
So 3x squared. There's no negative there, but
sorry,
3x
x,
squared.
yeah.
Great. And then this becomes
21. Negative 12x.
negative 21x. Great. So we got rid of fractions by doing cross multiplication instead of doing the whole LCD thing. If you want, you could still do the LCD thing that we just did earlier, but just when you have proportions, you could do a shortcut. You don't have to, but you could if you want. Okay, so now I still need to solve this, right? I still need to solve this. So in this problem here, what is the highest exponent here? 2. So is this a linear problem or is this a quadratic problem?
Quadratic.
This is a quadratic because the highest exponent is 2. So it's a quadratic. What do I need to use? The ZPP. So right away, I know I need to use a ZPP. Yeah, you know me. And Z stands for 0. So we need to set this equation equal to 0. How do I set this equation equal to 0? What should I do? Add 18 to both sides. So so this becomes a 0. I get 3x squared minus 21x plus 18. I put the 18 at the end because you want to write it in the quadratic form where the one with no x's goes at the end. What do I do after I set the equation equal to 0? You're going to factor it, right? So we're going to factor this. So this one's a little bit harder, right? Because you have a 3 in front here. So before you do X box, you should take out the GCF. Great job. All right, make our life easier. Remember that drawing of the hangman? The first thing you need to do is the GCF. Let's take out the GCF. That'll help a lot. So I take out the GCF 3. Inside, what do we get?
X squared minus 7x and then plus 6.
Great. Great job. So now doing the X box is going to be a lot easier with this than with that. So go ahead and now try doing the X box. Great job with finding the GCF. So go ahead and X box that. So now with this, you could just say what two numbers multiply to give you 6 and add to give you negative 7.
6 and 1.
Right? Negative 6 and negative 1. Because if you multiply them together, you get a positive 6, and you add them together, you get a negative 7. And again, this is partly why we spent so much time in the first week just learning how to add and subtract and doing mental math instead of plugging things into your calculator, right? Because you can't plug this into your calculator. You have to say, okay, do the mental math to find this. All right, so now this is equal to 0. Now they're factored. So again, here in the sheet, apply the zero product property. Once you factor it, you can set each factor equal to 0. So here, we can set each factor equal to 0. Well, these are the factors. 3 is a factor, x minus 6 is a factor, and x minus 1 is a factor. There's no use of setting 3 to 0. You can't put 3 equals to 0. There's no x to solve. Because the point is we want to solve for x, right? So we could set x minus 6 equal to 0, and we could set x minus 1 equal to 0. So the moment that you get things in factored form, you can set the factors equal to 0 because of the ZPP. So therefore, what is x equal to? 6, or x is equal to 1. But before we circle that as our final answer, we always need to double check, will those answers work if I put it in here? If I plug 1 in the denominator or 6 in the denominator, will I have a problem? So you plug 1 in first. 1 plus 1 is just 2. Here I plug 1. 1 minus 6 is negative 5 minus 7. I'm okay. It's not going to give me a 0. I'm just checking to see if I get a 0 in the denominator. So 1 I know is going to be an answer. So I'll check the easy one first, right? Then I plug 6 in. 6 plus 1 is going to give me 7, so that's fine. Here, if I plug 6 in, and I look at this, I'm like, you know what, let's save time. Instead of plugging 6 in here, why don't I plug 6 into its factored form? Here's the factored form of x squared minus 6x plus 7. If I plug 6 in here, do I get a 0? No. If I plug 6 here, will I get a 0? No. So you can plug it into this version, or you can plug it into the factored form. So plug in the one that makes that's easiest for you. So therefore, you have 2 answers for this problem, and then you're done.